taught pure mathematics. Okay, this webinar will be on quadratic expressions and quadratic equations, and this is a part one of, I think, about 4 parts. You'll see how things go. All right. So before we begin, because today is the first webinar in the series, let me introduce myself. Just a couple of slides, a few slides, just to introduce myself, so you know who I am. All right. So okay, just a quick introduction. Okay, I'm Dr. Lee. Okay, and I come from Klang. Klang is a city in Selangor, Malaysia. All right, and this is a very major bridge. It leads to a bridge in Klang. All right, I studied at LaSalle Klang, and LaSalle Klang has primary school, it has secondary school. I studied in both primary and secondary school. I spent 11 years in LaSalle Klang. And after that, I did my 6th form in ACS Klang. So lower 6 and then upper 6 in ACS Klang. And in 1986, I think in June or something like that, I left Klang to study in Singapore. So I enrolled at the National University of Singapore and I graduated in 1990. So 4 years after 1986, I graduated in 1990 with a Bachelor of Engineering in Chemical Engineering. And my first job was as an engineer, as a chemical engineer, but I quickly discovered that my calling was teaching. So I started teaching. First at Singapore Polytechnic from 91 to 98. And then after that for about 1 year and 9 months at Temasek Poly. And then from November 2000, I started teaching at NTU. All right, I've been at NTU since November 2000. So that's about 19 years and 5-6 months, something like that. Okay, I've got a collection of maths textbooks. This is my hobby actually. Collecting maths textbooks is kind of like my hobby. I've got nearly 1,000 maths textbooks from all around the world. And in fact, I've got a collection of all kinds of books. When I see a book that is interesting, I will just buy it. All right, so I've got a whole collection of all kinds of textbooks, all sorts of books, but they are stuck in my office. And thankfully, I have a few books at home so that I can prepare something, for all of you. So these webinars are being conducted on Mondays because Monday is, I'm very used to teaching in the evenings on Mondays. Every evening for the last, I don't know, something like 15 years, I've been teaching night classes on Mondays. And my last night class was last week. It was a final test last week for the students. And so this week, I thought let's just continue the momentum and teach completely for free. All right. So my approach to mathematics is this. If there's no pain, then there's no gain. So if you want to do well in mathematics, then there has to be some pain. And the pain comes from practice. No avoiding that. If you want to be good at mathematics, if you want to be fast, then you've got to train. It's like sprinting. If you want to be able to sprint very quickly, then you've got to train many times, right? So let's get started. So today's topic, there's 2 things here. It's quadratic expressions and equations. So there are 2 things here. It's quadratic expressions and quadratic equations. All right. So the first thing that you must ask actually is this. What is the difference between quadratic expression and quadratic equation? There are 2 completely different things here. All right. So let's go on and first things first, to distinguish what's quadratic expression and how is a quadratic expression different from a quadratic equation. All right, so you've got to know the difference, you've got to know what they look like. So within the first 5 to 6, 7 slides, the first set of slides, you see the first part of the slides, you will see that we are going to try to distinguish them, all right, to tell the difference. Now, let's look at quadratic expressions first. So we'll start with quadratic expressions. Quadratic expressions look like these. These are examples of quadratic expressions. So you have 3 examples here. So you see here, you have x squared plus 7x plus 4. This is a quadratic expression. All right, minus 7x squared plus 5x minus 6. This is also a quadratic expression. 2x squared minus 13. This is also a quadratic expression. And the thing about quadratic expression is this. The x squared term must be present. All right, all the other terms, believe it or not, they are optional. All right, the only term that must be present in order to make an expression a quadratic one is an x squared term. All right, so all the other terms, the 7x here is optional, the 4 here is optional, the 5x here is optional, the minus 6 is optional, the minus 3 is optional. So as long as you see an x squared term and nothing higher than that, no x cubed, no x to the power of 4, no x to the power of 5, no x to the power of 6, as long as x squared is the highest term you see, the expression is a quadratic expression. Okay, all the other terms, let me stress, they are all unnecessary, they are optional. Now you may be asked, you know, after this class, what's the simplest quadratic expression? Well, the simplest quadratic expression is simply x squared. Right, so if you have just x squared, now this is a quadratic expression and this is the simplest quadratic expression in the world. So examples of quadratic equations. Okay, now you have seen quadratic expressions already. They look like this, and as I've stated that it's a x squared term must be there, right? So what's the difference between a quadratic expression and a quadratic equation? Now these are examples of quadratic equations, and you see that there is an equal sign here. All right, so equations, you must see the equal sign. Expression, the equal sign is not there, right? It's not there. So for the equation, the equal sign is there. All right, so these are all examples of quadratic equations. And again, if you look at quadratic equations, not only the equal sign is there, but you also have the x squared term as the highest, the term with the highest power is x squared. The x squared term must be present. The equal sign must be present in order for an equation to be a quadratic equation. So the equal sign is present and the x squared term is the highest term there. Okay. Now, so the simplest quadratic equation is simply x squared equals to 0. So you know now the simplest quadratic expression and also the simplest quadratic equation. Now let's look at some quadratic equations, okay, the ones that we've looked at here. Now let's take a second look at it, okay. If you look at these quadratic equations, they are equations because they have an equal sign here, right? That makes them equations, all right? And the x squared here being the highest power of x makes them a quadratic equation, all right? Now you will see that it's very messy, man. It's very messy because here you have, you know, like minus, you have x squared on this side of the equal sign. You have some terms on the other side of the equal sign. Again, here you have x squared here on this side and 13 on the other side. It's really messy, okay? And because it's messy, mathematicians have come out with this thing called the standard form of a quadratic equation. And this is one of the first things you must master, all right? You must be able to recognize, firstly, you have to be able to recognize what is a quadratic expression, all right? After that, you've got to be able to recognize what's a quadratic equation. And you've got to realize that quadratic equations are messy and that there is a standard form of expressing a quadratic equation. So this is the standard form. You have ax squared plus bx plus c equals to 0. This is how a standard quadratic equation in standard form looks like. All right, so if you see a quadratic equation in this format, it's called the standard form of the quadratic equation. Okay, so I stress here is the standard form, and you know there are certain a few characteristics that make it, you know, that you must know about the standard form of the quadratic equation. Firstly, everything and everything here is in inverted commas. Everything is on the left side. You see that everything is on the left side. On the right side of the equal sign is just a 0. 0 means nothing. Okay, so everything is on the left side. On the right side, there's nothing, 0. Now, everything on the left side is arranged nicely. And what in the world is the, you know, what is in the world is meant by nicely? What is meant is this. Nicely means this. The x squared term comes first. After that, this is followed by the x term. After that, this is followed by the constant. All right, so there is an order. The highest power of x, which is x squared, comes first. And then after that, the x term comes. And then after that, the constant. So this is the second characteristic of the second form, the standard form. Everything is on the left side. All right, and everything on the left side is arranged kind of nicely in a certain order. Okay, now the third one is this: everything on the left side is equal to 0 on the right. So these are the three characteristics of the standard form of a quadratic equation. Let's repeat this. Let's revise. Everything is on the left side. You will see on the right side is just a big fat zero. All right. Everything on the left side is arranged nicely. What do we mean by nicely? When we say nicely, we mean that there is an order. X squared comes first, then X comes first, followed last by the constant. All right, and everything on the left side is equal to the zero on the right side. Okay, so if you have a quadratic equation that is in this format that looks like that, we call this a quadratic equation that has been expressed in the standard form. Okay, now I'd like to stress this: in the standard form of a quadratic equation has as order. All right, so if you look at the quadratic equations here, these are all already quadratic equations. All right, they are not in standard form, they are already in they are quadratic equations though. So let's see how to transform these quadratic equations into the standard form. All right, so you have this one here which needs no transformation because it's already in the standard form. So this is already in the standard form. You don't need to do anything. All right, it's already perfect. It's already in order. It's already nice. Everything on the left side is equal to zero already. No need to do anything. Now, this one, on the other hand, you will see that to transform it into the standard form, we need to bring this 6 over. And when we bring this 6 over, we get a minus 6. We need to bring this minus 5 over also. And when we bring this minus 5 over, we get a plus 5. All right. So when we bring this 6 and it becomes minus 6, we bring the minus 5 over and becomes plus 5. We see that the x squared comes first, followed by the x term, followed by the constant equals to 0. Now this is the standard form already. We have arrived at the standard form. All right. Now this one here, again, the 13 is over here. So to get to the standard form, what we do is we bring it over to the left side and it becomes a minus 13 equals to 0. This is the standard form. All right, the right must be a 0. And here, same thing. We bring the minus 7 over here, we get a plus 7. We bring the minus 9 over, we get a minus 9. So this is what we have, all right, as a standard form. The x squared is the same. 9 here becomes a minus 9 when it is brought over. Minus 7 becomes a plus 7 when it's brought over, and you have an equal to a 0 here. Now, again, you know, let me stress this. You know, I've used this word here, and I like this word a lot. But the standard form of a quadratic equation is characterized by order. And if you look at this side, it's, you know, it's chaotic. It's just chaotic. There are terms on the left side, there are terms on the right side. You know, everywhere you have terms, you know. But, you know, and so here the adjective that's suitable here for this quadratic equations that are not in the standard form is chaotic. Whereas on the other side, you will see that, you know, the quadratic equations are kind of orderly. All right, so I want you to remember these two words. Quadratic equations that are not in the standard form are chaotic. Quadratic equations that have been transformed into the standard form, they are all orderly. All right, you can see that it's equal 0, equal to 0, equal to 0, equal to 0. They are really, really, really neat and nice and orderly. Okay, now the next question is this. Okay, now couldn't we have just left it in the chaotic form? Why, you know, why did we have to make it orderly? This is nice too, what? It's chaotic and nice. What's wrong with being chaotic? What's wrong with this? What's so great about being orderly? So here, order is important because the order in the standard form of the quadratic equation allows us to identify what's A, what's B, and what's C. That is why the order is important. All right, so chaotic is fine, but we make it orderly so that we can identify what's the value of A, what's the value of B, and what's the value of C. So here, let's look at this, this quadratic equation in standard form. This is already in standard form. Here, let's identify A, B, and C in the quadratic equation above, already in standard form. So here you will see that it's very easy. A is 1. X squared here means that there is a 1 in front. So A is 1, B is a 7. If you compare with this, B is 7. All right. And if you compare with this, C is 4. All right. Very, very easy to identify A, B, and C once your quadratic equation has been transformed into the standard form. Now let's look at this other quadratic equation. All right. And A, obviously, if you compare this with this one here, A is obviously minus 7. B is obviously plus 5. And C is minus 6. You can see that how easy, you don't have to get a calculator, you don't have to get anything. From just visually looking at it, you know what's A, what's B, what's C. This is why the standard form is so important, because if your standard form has been set up nicely, if your quadratic equation has been expressed in a standard form, identifying A, B, and C is a visual thing. You don't need to calculate, you don't need to manipulate, you don't need to adjust, you don't need to shift here and there, bring it here, bring it there. You don't have to adjust the terms. Everything is right there in front of you for you to see. Now here is a little tricky. Identify A, B, and C here. Now A is obviously a 2 because if you compare this, A is a 2 here. Now there is no X term. So because there's no X term, B is a 0. All right, B is a 0 here because there's nothing that has an X here. All right, and C is a minus 13. So C is a minus 13 here. So A is 2, B is 0, and C is minus 13. All right, so here you can see again, once you have expressed a quadratic equation in standard form, identifying A, B, and C is easy. Now the last one here, the fourth one, all right, identify A, B, and C again, and you can do this. A is a 1, B is a minus 9, and C is a 7. Very simple. All right, I'm sure you have, you got the hang of things already. All right, by this point, I'm sure you've already got the hang of things. Now the next question is this, I said that, expressing a quadratic equation in the orderly form of the standard form, orderly, kind of format of the standard form is important because it helps us to identify A, B, and C. And the next question you should ask me is, why do we need to identify A, B, and C? All right, why do we need to go to the trouble of identifying A, B, and C? Why do we need to know the values of A, B, and C? What we have done here is to identify the value of A. What's A? A has a value of 1. What's B? B has the value of minus 9. What's C? C has the value of 7. So when we say identify A, B, and C, what we mean is find out the values of A, B, and C. And your question here is, why do we need to find out the values of A, B, and C? Why is it so important for us to find out the values of A, B, and C? Now, it's important to find out the values of A, B, and C because the values of A, B, and C provides us with an idea of how the curve looks. All right, it helps us to plot, it gives us an immediate idea of what the curve looks like just by knowing A, B, and C. Isn't that magical? It's just absolutely amazing. Okay, so here, the most important number out of A, B, and C, the number that you must zoom into immediately, the first number that you must get your hands on is this A. A is like super important, and it's the first number you need to get your hands on. It's the first number that you need to get your hands on because A tells you whether the curve opens upwards or the curve opens downwards. It's that useful. If A is the value of A is 5, you know that the quadratic curve opens upwards. If the value of A is minus 3, the curve opens downwards. So A is really useful. All right, it should be, when you look at a quadratic equation in a standard form, your eyes should immediately grab A. Right, it should immediately look at A, and you should immediately be fixated at A and look at the value, because A tells you whether the quadratic curve opens upward or the quadratic curve opens downwards. So let's say that A is 9, it opens upwards. If the value is minus 4, it opens downwards. All right, so that's what A tells us. All right, and so you can see how useful it is already. So identify A, B, and C. We have done this already. We won't go through it again. And A is A is 1. What does that tell you? That tells you that the curve looks like this, right? We haven't plotted the curve yet. We haven't created a table of values for x and the value for the expression, but we already know it looks like that. How? Just by knowing the value of a. The value of a, 1 is greater than 0, so it must look like that. Okay? Now again, we have done this already, so I'll just give you the a, b, and c here. And a here is -7. -7 tells you that the curve, the quadratic curve, must open downwards. So it must look like this. All right, whatever it is, we can plot the values later, we can create the table of values later, whatever it is, the quadratic curve must open, must open downwards. Okay. Now here the a is 2 again, it's like that. Why? Because a is greater than 0. 2 is greater than 0, so it must open upwards. All right, and again here a is 1. 1 is greater than 0, so the quadratic equation again opens upwards. All right, so quickly, let's just recap. All right, of the 3 numbers, your attention must immediately go to a. When you look at a quadratic equation in the standard form, your eyes must quickly go to a and capture the value. Why? Because it tells you whether the curve opens upwards or opens downwards. All right, if the a is positive, it will open upwards. If the a is negative, it will open downwards. Now let's go on. So, okay, a is damn useful. Now, why do we have to a is damn useful, right? But why do we have to get the values of b and c? A good enough already, what? All right, why do we need b and c? What's the usefulness of b and c? Now, b and c is useful because a, b, and c, all 3 of them are used to calculate this thing called the discriminant. All right, and the discriminant is calculated using this formula. The discriminant is often given the variable d. So d is the discriminant. D is b squared minus 4ac. This is called the discriminant. And you can see that to calculate the discriminant, you need the values of not just a, but also b and c. And this is where the value of the values of b and c become very useful. So here, why is the discriminant important? Now I'm asking you these questions and not showing you, just the working, because I want you to know the why in maths here. Maths, there's a lot of whys. The problem is many students, they just go and straight away do the questions without understanding the why. All right, okay, calculate discriminant. But you ask the students, why are you calculating this? They have no idea at all. So here, why do we need to calculate the discriminant? Now, the discriminant is important because it helps us to discriminate. All right, why is the discriminant important? Because it helps us to discriminate. Now, what are we discriminating about? What do we discriminate? Now, there are 3 things that we want to discriminate, 3 different cases. The first one is whether the curve misses the x-axis. The second one, the curve touches the x-axis. The third situation, the curve cuts the x-axis. All right, so how do we discriminate among these 3 cases? We discriminate by using the discriminant. All right, so if somebody asks you, why are you calculating the discriminant? Why do we have to calculate the discriminant? The answer is we calculate the discriminant because we want to discriminate. What kind of situations do you need to discriminate? You need to discriminate between 3 different situations. Whether the quadratic equation misses the x-axis or touches the x-axis or cuts the x-axis right through. Okay, so this is what you're discriminating. So a is greater than 0. Remember, a is greater than 0 tells you that the curve opens upwards. That's what a greater than 0 tells you. But it doesn't tell you whether the curve misses the x-axis or touches the x-axis or cuts the x-axis. It doesn't tell you, it just tells you that it opens upwards. Now, what will tell you whether it misses or touches or cuts is your discriminant, right? So if your discriminant is less than 0, then your curve will miss the x-axis. If your discriminant is equal to 0, your curve will touch, beautifully just touch the x-axis. If your discriminant is greater than 0, your curve will cut through the x-axis. And you can see that here there are no real solutions. There are no real solutions because there's no value of this curve where it is 0. All right, and here there is one real solution, and the real solution is right here at this dot here. This is where the real solution is. All right, now here there are two real solutions because one solution is here and one solution is right over here. All right, so here you must know, don't just calculate your discriminant blindly. You must know why you are calculating your discriminant. You calculate your discriminant because you want to discriminate. What are you discriminating? You are discriminating between these three cases. All right. Now let's go on to the other case. The other case is a is less than 0. So a is -1, a is -4, a is -13, a is -300. The curve will look like this, opens downwards. But again, a is smaller than 0. It doesn't tell you whether it's like that or it touches the curve or it cuts the x-axis. What tells you, what enables you to distinguish between these three situations is your discriminant, is your big D, discriminant. All right. So if your discriminant is less than 0, it's a negative number. Again, you have this situation where it misses the x-axis. All right, it misses the x-axis. You can see that it missed the x-axis. Here, it merely touches the x-axis. Here, it cuts the x-axis at 2 points. Your discriminant is greater than 0. All right, so let's determine the shape. We are not plotting anything. We are not interested to plot anything yet. Okay, we don't want to plot anything. We just want to determine the shape of this one. Again, the same focus. All right, and here you see that A is 1. It tells you that it opens upwards. And the discriminant, you took the B squared is 7 squared minus 4. 4 is a constant, so just put a 4 down. A is 1, C is 4, so it's a 49 minus 16. This is a 33. 33 is positive. All right, that means it has 2 real roots. That means the curve looks like that. We don't know the exact values yet, and we don't have to at this point. All right, but you already know what curve, what shape of curve to expect already. All right, by just knowing A and the discriminant. Now for this one, the second curve, we are just going to go through 4 curves only. If for this particular curve, you see that A, we have gone through this. Now we calculate the discriminant. B square is 5 square minus 4, A is -7, C is -6. So here, if you calculate, is 25 minus, if you calculate this out, is -168. All right, take your calculator, your Casio calculator out and calculate. You will get a 168 here. You perform this calculation, it's -143. This is a -143. That means that the curve missed the x-axis. This means that it opens downwards. This means that it missed the x-axis. So the curve looks like this. Again, just by A and B, A and your discriminant, you can see that your curve, the shape of your curve comes out immediately. Beautiful, beautiful. Okay, so here let's look at it. A, again, we have done this. Calculate the discriminant now. B here is a 0, so it's a 0 minus 4. A is a 2 here. C is a -13. Now look at how neat this calculation is. This calculation is so neat because I have everything all prepared already. Okay, so when we do this calculation, this minus and the minus here, excuse me, they cancel out. So minus and minus becomes positive. So that becomes a +104. So here D is a positive. A is a positive also. That means it opens upwards. D104 means it cuts at 2 points. You have 2 roots. So that's what it looks like. You see how useful, catching the value of A and calculating the value of discriminant is extremely useful. It tells you the shape of the curve straight away. Last one. Determine the shape of this one here. Again, we are not interested in the precise values. We just want the shape for now. So this we have done. Now we calculate the discriminant. B squared is -9 squared, -4, A is 1, C is 7. So we put all this together. -9 squared is 81. -9 times -9 is 81. -4 times 7 is 28. So 81 minus 28 gives me 53. So here you have a positive, here you have positive again. This positive, this one here tells me that it opens upwards. The curve opens upwards. This one here tells me that there are 2 roots. 2 roots. Okay, so this is what the curve looks like. Okay, so I hope you have an idea of why it is important for you to, number one, express your quadratic equation in standard form. Why is it important? It's important because from your standard form, you're able to identify A, B, and C, the values of A, value of B, value of C, easily. Now, the second question is, why do you have to do that? You have to do that because A itself tells you whether the curve opens upwards or opens downwards. Now, with your A, B, and C, you need all three. You can calculate the determinant, the discriminant, and your discriminant will tell you whether it cuts the x-axis, it touches the x-axis, or it downright misses the x-axis. So with just these two, the shape of the quadratic curve is already settled. You understand it, you know how it looks like. Okay. So next, having understood what the shape is, the next type of question that's very common for quadratic equations is solving it. Now there are four ways to solve. And covering all the four ways in one lecture, in one webinar is just too much. So what I'm going to do is I have, I think, 4 weeks. All right. I told you every Monday, I'm very used to teaching on Monday nights. My Monday night class, my night class on Monday. Anyway, what I'll do today, because there are 4 ways of solving quadratic equations, I will teach you graphing today and factorization next week. Following week, I'll teach you completing the square. And then after that, I will teach you quadratic using solving quadratic equation using this particular equation, which is unfortunately also called the quadratic equation. All right. So today we'll talk about graphing. Next week, 2 weeks from now, 3 weeks from now. All right. So come back, all free, no charge. Okay. Just I'm just occupying my time. I am very, very relaxed, and I feel very good if you benefit from this. So today we'll just talk about graphing. So here, let's say your question is like that: solve x squared. These are the same questions that we have seen. I'm using the same questions over and over and over again, so that I drum it into you. So here, let's solve x squared minus 7x plus 4 equals to 0. Let's solve this. Now, oops, okay. Now let's solve this one here. So to solve this, what you can do is graphically. There are 4 ways of solving. I'm showing you this graphical method. We are not touching on factorization. We are not touching on completing the square. We are not touching quadratic equation. I'm just going to show you graphing. Now, to solve it by method of graphing, what you do is just very simply have a range of values of x. Here I've got -7, -6, -5, -4, -3, -2, -1, 0, 1, and perhaps there's a 2 there. Is there a 2? No, just ends at 1. Okay, so you have the x values there, and you use this equation, y equals to this, to calculate your y. All right, so if you dump your x, if you substitute your -7 here, your x value is -7. So -7 square is 49. 49, this is -49. So 49 minus 49 is 0 plus 4. So you have a y value of 4 here. Just complete your table. -6 here will be 36. 36 minus 42. 36 minus 42 is -6. -6 plus 4 is a -2. And so on and so forth. Just go ahead and complete, this x, you just fill it in, y you have to calculate. All right. So once you have filled this thing in, you see that between -7 and -6, between this and this, between x equals to -7 and x equals to -6, between these two numbers, you will see that y becomes 0. At x equals to -7, y is 4. At x equals to -6, your y is -2. So somewhere in between, y is 0, has got to be 0. So one of your roots occur in this range from x equals to -7 to x equals to -6. Between here, there's one root. Now you see also, it's the same thing happening here. At x equals to -1, your y is -2. At x equals to 0, your y is 4. So somewhere in between here, somewhere between -1 and 0, there's another root. Definitely there's another root here. Okay? So really, what you do is you plot this one out, and you all these points, 4, -2, -6, -8, -8, you plot them out. 4, -2, -6, -8, -8, you plot it out, and once you plot it out, After that, after you plot out the points, you just connect it with a smooth line here, and you will see that exactly as we have anticipated, between -7 and -6, there is a root. This is -6, -7 is here. This is -4, this is -5, this is -6, this is -7. Between -6 and -7, there is a root, as we predicted by looking at this. And there's another root also between -1 and 0 here. This is -1 and this is 0. So if you connect the point, there must be a root between -1 and a 0. Okay, now what the root is, we maybe have to squint our eyes, all right? And my eyesight isn't that great, okay? Now we have to squint our eyes and we can see that this is roughly -6.5. This is roughly -0.6, -0.7, somewhere there. So that is the drawback of the graphical method. What is the drawback? What is the disadvantage? The disadvantage is this: your roots are all estimated by eye. All right, by eye. There is a problem of the graphical method. Okay, I don't know what is this exactly, but I know roughly. Okay, now let's look at another one. So here you have solved 2x² minus 13, and I've done the same thing. I've -4, -3, -2, -1. All these are x values that I put up here. All right, and these are values that I calculate. So -4 squared is 16. 16 times 2 is 32. 32 minus 13 is 19. So here -3 will be 9. 9 times 2 is 18. 18 minus 13 is 5. So just put a range of x values and then calculate your y values here. Same. And then after that, note that there is a root in between -3 and -2. How do you know there's a root? There's a root because there's definitely a root because you have a value of 5 or y here, and then here it becomes -5. Somewhere in between here, it must be 0. Somewhere, we don't know where. All right, but somewhere there must be a 0. Y must become 0. Same here, between the x value of 2 and x of 3, the y must become 0 somewhere. All right, so once you have this table and you have made these initial guesses, plot your points and then, follow it up with a smooth line. And you'll see that definitely there is a root as we have estimated between 2 and 3. This is 2, this is 3, this is 4. So between 2 and 3, roughly 2.6 or something like that. As I said, we have to estimate this is 2.6. There's a root here. This one here is -2.6 or something like that. This is -2, this is -3. So this is -2.6. There's another root roughly over there. So these are our roots there. Okay, now at this point, I want to share with you a top secret. This is a top secret that most of your teachers don't want me to say, all right, don't want me to share, but I will share it anyway because it's a very, very, very super useful thing. Now, let's say I want this plot, okay, now, and I want to plot this. What I can do is this. Let me share my Google. This is my Google here. All right, this is the first time I'm using Zoom for teaching. So if I mess things up, please excuse me. Yeah? So this is my Google. So here, if I want to plot x² plus 4x plus 7, this is how I do it, believe it or not. Just x², this one here means square, plus 4x plus 7. This has to be an expression, which simply means, as I've stated at the first slide of this lecture, expression means there's no equal sign. It has to be an expression. So once you press x², you type in x² plus 4x plus 7, if you enter, you will see the curve nicely here. Wow, nice or not? It's wonderful, right? So let's see, let's go back. Okay, the equation that we solved just now was x² plus 7x plus 4. Sorry, it was x² plus 7x plus 4. Okay, so this is the curve we were plotting just now. All right, there's a root somewhere here. All right, there's another root, between -6 and -7, there's a root. Between -1 and 0, there's another root. And you say that, my goodness, it's lousy because here again, I have to estimate what is so good about this curve. This estimation is also I have to do. So anyway, you can shift the curve here. and you can use your what do you call that now? The roller on your mouse. Your mouse as a roller. You shift the mouse roller. You can see that I can make it really super accurate, super zoom in. All right, and you can see that the root here is roughly. You look at this here. Please look at this here. All right, you can see that the root is, look at that, is minus 0.629. Your estimate need not be dependent entirely on your eyesight. Google.com always comes to the rescue, and this time it hasn't failed us. It's come to the rescue also. So one root here is x equals to minus 0.629. There's another root all the way to this side, right? So let's go over the side very quickly, and we zoom in, zoom in, zoom in, zoom in, zoom in, zoom in. There's another root here, which is minus 6.3722997. Now, how good is that? How fantastic is that, man? That is absolutely super amazing, right? Now, the other one that we solved was 2x squared plus 13. 2x squared plus 13. And 2x squared plus 13, this is, 2x squared minus 13. That was the second thing we saw, right? 2x squared minus 13 looks like this. And again, if you want to look at the root graphically, just zoom in, zoom in, zoom in, and put your cursor right at the root here and look at here. All right, look at it here. Okay, look at it. It's 2.54922311. All right. Very good estimate. And the other side, just go over the side and zoom, 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 zoom. And you've got the same thing. Wow, it's minus 2.5512, blah, blah, blah. You get the idea. You get the idea. Now, this is using Google to plot graphs. Google is super useful. No? It's really super useful because you can plot more graphs like this. Let's say you want to plot y equals to x minus 1. So x minus 1. And you will see that there are two curves there. This is your 2x squared minus 13, this one here. And this one here is your x minus 1. Don't you think it's like damn good? It's very useful. It's very useful because you, without paying a single cent, you are already watching this webinar, all completely free. Without paying a single cent, you are also getting a graphical calculator free, completely free. And again, you can zoom, see where the intersection is. The intersection is right there. That's your intersection. Your intersecting point is 2.7109 and y equals to 1.698, blah, blah, blah. You can get the intersection point. And if you want to add a third curve, why not? Why not? Why not? Since we are at it, let's add a third curve. Sin x. Oh, gosh. All right, there's a third curve there. This one here is a third curve here. All right, so you can plot. I've only tried two, okay? Only for this webinar, I've tried a third curve. I don't ever see a use for plotting three curves at one time. But anyway, you get the idea. And let's get back to our slides, okay? Let's get back to the slides because we have to get back to the slides. And this is, okay, this is the slides back. Okay, and where am I, man? Let me get back to the slides. Okay, so I've gone through all these things. I've gone through all this stuff already. Okay, so let's just go to the top secret kind of like systematically. All right, the first thing is you can use Google to draw graphs, and that's how you do it. All right, just put an x squared plus 7x plus 4 here, and you can, Google starts to draw already. Okay, no problems, very easy to draw graphs. And let's analyze this carefully. So this one is x squared. To draw y equals to x squared plus 7x, just put x. This sign here is called a caret. All right, C-A-R-E-T, caret 2 plus 7x plus 4. All right, so here, this symbol here is called caret. It's called a caret sign. Okay, and that stands for raised to the power of. So this is x raised to the power of 2. And to get that, it's shift 6. Look at your keyboard right now, shift 6. Look at the key for 6. You will see that this caret is on top of the number 6. And just shift 6 to get this one here. Remember, this has to be an expression. So do not key in the y equals to. All right, so x to the power of 2, x raised to the power of 2 plus 7x plus 4. That's how you read this. Okay, it's the same as this one here. Now, so when you use Google to draw graphs, that's what you get. You can use your mouse, sort of like your wheel here to adjust. And when you adjust, you can use this to adjust as well. I'll let you play around with this. Okay, you can plot 2 or more curves simultaneously. I've only used 2, all right, but here I've shown you that even if you want to plot 3 also can. What you have to remember is use comma to separate the expression. Just use comma, separate your expressions. Remember, they have to be expressions. Equal signs not allowed. Okay, so it's a comma. All right, so I've demoed to you already. Now, warning is this, use Google, because I've shown you this little secret right now, and you will be now like, wow, why do I have to plot out my curves manually? Can't I use Google all the time? Now, that's why I have this warning here. Now, use Google only for learning and for checking your answers. Because if not, you will not learn how to draw the graphs on your own. So Google is great, but use only for learning and for checking your answers. Remember that you don't have Google in your O-levels, SPM, or whatever exams, IGC, SE, I don't know, whatever exams you're taking. Okay, I've selected quadratic equations because it's there in every syllabus. Quadratic equations is so important. So wherever you are in, you're in Singapore, Malaysia, Thailand, wherever you're viewing this from, remember that you don't have Google in your examinations. So don't get addicted to Google for graph plotting. Don't rely on Google for graph plotting. So here I have sent you 2 files already. I've sent you 2 PDF files. The first one is very simple. The second one is optional, but the first one is critical. So complete your 6 questions, all on graphing, because today we've covered graphing only, and the estimation of roots. So you will need graph paper, and the PDF has probably been sent to you. I don't have your email addresses. I don't have anything about you. I don't know anything about you. So the PDF you probably already received, and use Google to check your answers. Now that you know Google can plot. Okay, now so we are going to come to a close here. So, so let's look at what we did today. All right, so today, we started off by differentiating what's a quadratic expression, what's the difference between a quadratic expression and a quadratic equation. An equation has an equal sign. Expression doesn't have. And quadratic, the highest term must be x squared, and the x squared must be there. Die, you must have x squared term. We also learned the standard form of the quadratic equation and why you need the standard form. Remember, the why is important. Why do you need the standard form? You need the standard form so that you can identify A, B, and C. Why do you need to know A, B, and C? You need to know the A, B, and C because by knowing the A, B, and C, you will be able to know the shape of the curve. So we have also seen how to draw a quadratic equation, quadratic curve using the table. You get all the x values, and then you calculate the y values, and then you put the points there, and then you draw the curve, right? So we've seen how to draw a quadratic curve. We've seen how to estimate the roots of a quadratic equation using the curve that you have drawn. And then the last one is the top secret that I've shown you. Google can be used to draw graphs. Okay, so in the next webinar, not next video, next webinar, so what I'll be doing is factorization. So in the next webinar, we'll talk about factorization. In the third one, we'll talk about completing the square. The fourth one, we'll talk about quadratic equation. And every one of these, I'll give you 1, 2, 3 kind of like PDF files containing questions to work through. So make sure you work through. All right, and there's an appeal here from me because I cannot go anywhere also. I'm at home every day. I don't have access to past year exam questions, whether it's Singapore one, Malaysia one, Thai one, or whatever it is. I don't have access to past year questions. So here I have taken some questions. I've created some questions. I've created some of those quadratic equations you have seen. So if you have some past year questions on quadratic equations, all right, let's stick to the topic of quadratic equations. You have some past year exam papers. Now you can email me the exam questions at this particular email address, all right? And so really, thank you for watching. And if you found this useful, then, I'll see you again for another webinar next week. And this is my YouTube channel here. If you're interested for free videos, completely free, everything free. And if you want to contact me, this is my email address here, same as the one here. All right. So thank you. And I hope to see you next week. Bye-bye. Yao Chan, pass over to you.
Yes, Dr. Lee, thank you very much. And thank you very much everyone for joining. So we'll continue the next lessons on next Monday, same time. Hope to see you all again. Thank you very much. Thank you. Bye-bye.